Hey guys, so in this video I'm going to talk about the inner product of two vectors. So you can say inner product or you can say dot product, either is fine. So let's say I'll probably write here.
Now let's say we have two vectors. One is u1, u2, u3 and u4. Let's assume. And the other one is v1, v2, v3 and v4. So we have two vectors here. Now out of these two vectors, if I want to basically find out the multiplication, basically inner product or dot product of these two vectors, I'll first of all I'll just transpose one of these vectors. So I'll probably write this notation like this. So it will be u, t and v, and ut, u to the power t, this part is basically the transpose of u. And when we do multiplication for vectors, and you'll also encounter this in when we do the matrices multiplication. So when we do this multiplication, we have to have basically we have to transpose it, because our a number of columns for the first uh, vector should be equal to number of rows in the second vector. So of course we'll discuss more about this when we go to matrices. So let's say this is the as of now, let's you can just know that we have to just use this notation utv. So we have to transpose u. So when we transpose u, we'll write it like this: u1, u2, u3 and u4. It will become like this. So the rows, all the rows will become the columns, and the v will remain same. V will remain same. It's like v1, v2, v3 and v4, right? So now we have to find the multiplication of these two. So okay, so that's what we have to do. Now what we'll do is we'll take the multiplication of first row. So as I said, the first all the different rows will become all the different columns, and of course if there's only one column, it will become the row in this when we transpose it. So there's one column and the column will become rows, and all the individual constituents which were actually part of the row will become part of the column, different columns. So we'll have four columns now, but one row. Here we had one column and four rows. In this place we had four rows and one column. Here we have four column and one row. So now what I'll do, I'll multiply the first row with the first column with individual corresponding elements. So it will be something like u1 into v1. So this will be multiplied to this will be multiplied to this, individual, second to second row, second column here, second column here, to second row here. This one this, and this one goes this, like so. Then plus, then u2 into v2 plus u3 into v3 and plus u4 into v4. And that's how we solve it. I also take some arbitrary numbers and show you the calculation with the numbers as well. So let's say let's assume I'll probably have another. Let's say we have numbers like 1, let's say -3, 8 and 9. That's the first vector we have. And then we have another vector. Let's say we have v vector, which is -1, 2, 3 and -9. This was 4, right? Now if you remember, I had to transpose u. So I'll write it like this: 1 minus 3, 8 and 4, right? Then we had v, so I'll write it like this: minus 1, 2, 3 and minus 9. Perfect. Now if I multiply it, I'll do this: 1 into minus 1, that is this goes multiplied with this, plus minus 3 into 2, this multiplied with this, another plus 8 into 3, this multiplied with this, and this multiplied with this, 4 into minus 9. To avoid confusion, I'll put them all in brackets. And now if we calculate it, how we do it? Minus 1, this one would be 2 3 2 3 6 minus 6, this one would be 8 3 24, and this will be minus 36, perfect. Now if we sum this up, it'll come to minus 43 and 24, minus 19. So that will be my answer for this dot product for these two vectors. So I hope you understand, and I hope I was able to clearly explain this. It's an easy multiplication. We'll see more of this when we actually do the multiplication for the matrices. So matrices use a lot of multiplication in this way, where we are basically relating the rows of one matrix to the column of other number of columns of other matrix. So as of now, that's it for this video. Thank you.